Welcome to the hobby world of Dr. Mike. In this video we'll be talking about repairs I made to World Cup pinball machine sound card. The World Cup pinball machine was Williams' first pinball machine with synthesized sound. There was actually an error made on the printed circuit board associated with the volume control. So we'll go over that and how to correct it in this video. Here's the sound card. These integrated circuit sockets are about 45 years old and they lose their ability to make good connection. You can reseat the chips into the sockets and work for a little while, but a little while later it will stop making good connection and you'll lose your sound. The potentiometer was also noisy, so we'll replace the potentiometer. And while we're working on the board, we'll go ahead and replace these electrolytic capacitors. There were some corrections to the sound card that Williams needed to make. And of course, before you start pulling the sockets off, you need to keep track of the corrections and the jumpers. You want to make sure that you reestablish the jumpers in the correct locations. Here's a sound card with the components removed. I used a desoldering station to prevent damage to the foils on the printed circuit board. I found a radial capacitor and not an axial capacitor of the size I needed, so I drilled some holes so I can mount the radial capacitor onto the board. Of course, I was careful not to drill through any of the foils on the printed circuit board. On the left side is the old potentiometer, and on the right hand side is the new potentiometer. Of course, I wired the potentiometer to the printed circuit board in the same manner. And again, I was not able to get good volume control out of the potentiometer. Let's talk about the volume control for a little bit. Here's the volume control potentiometer. Takes a small level signal and basically sends it through a resistive voltage divider and then to the amplifier and then to the speakers. When the potentiometer is set close to this ground level, the volume is 0. When the potentiometer is set to its highest point, the volume will be higher. These volume control potentiometers have what's called a logarithmic taper. Now, it's not truly logarithmic. We'll call it piecewise linear, but it basically follows a logarithmic curve. So if you have your potentiometer set down here, the ohmic value is very small compared to the total resistance of the potentiometer. But you need this logarithmic scale to get good volume control. So that you'll have, for argument's sake, we'll call it relative volume. So for 10% relative volume, you need very small ohmic value here, very small signal going to your amplifier. And the ohmic value goes up gradually to get a higher volume level. You can see here, for example, for a 50% volume level on a 5 kilo ohm potentiometer, you'll be set at basically 500 ohms. This will give you approximately 10% of the total signal into your amplifier. Now, if the potentiometer is hooked up backwards, as it is in the case of this sound card, then you'll have a very high resistance jump at the lower volume levels. So here you can see about 10% of your volume control on the lower end. You'll range between 0 and 60% of your relative volume, which gives you a very small range for good volume adjustments if you want lower volume. Otherwise, you're sitting at 90 to 100% relative volume for most of the range of the potentiometer. To get good sound control, you need the wire from this point on your PC board to this terminal, and need the wire from this point on the PC board to this terminal of the pot. Again, that'll give you good sound control